Well guys, welcome to another episode of Dev's Kingdom. This is Jacob. In this tutorial, I'm gonna go through the latest release of Dolphin 3.0. So Dolphin 3.0 is the next generation of the Dolphin series of instructor tuner models, designed to be the ultimate general purpose local model. So basically, Dolphin 3.0 is based on all the popular models like Llama 3.2, Qwen 2.5, and also Llama 3.1. So basically, they have high quality datasets to fine-tune those models. And for example, if you go to the Dolphin 3.0, Llama 3.1 8B GGF, you can see that they basically fine-tune on Hugging Face, Smalltalk datasets, Microsoft Oracle datasets, and LLM Tulu datasets, which is very, very popular and very cool datasets. So if you go to the files, so basically this GGF have a lot of quantized versions. You can actually pick one of them, but today we're gonna use the 4-bit version. And so if you go to Kaggle.com, create a notebook, we're gonna go through step by step to show you how to build Ollama and OpenWebUI on Kaggle using the latest Kaggle kernel. So this is a little bit different setup than the older Kaggle kernels, which were based on Conda. So in the latest Kaggle release, they basically don't have Conda anymore. So we're gonna show you how to do that. So we already spin everything up. So we're gonna basically go through step by step to see how to set up a web UI on the latest Kaggle kernels. So that being said, let's continue with the Kaggle notebook. So create a notebook on Kaggle.com. If you don't have one, just register Kaggle.com and create a notebook similar to this one, Ollama OpenWebUI, and then you can actually run the Python 3-v and also Conda to see if Conda exists. So in this case, Conda doesn't exist. You can see the Python also is 3.10, but OpenWebUI needs 3.11. So we have to install and build the 3.11 of Python. So that being said, let's continue. So first we have to install Conda. And first we have to make a directory of mini Conda 3 and also get the latest mini Conda from Anaconda's website and dump it to this Miniconda folder. And after that, make sure you run the Miniconda script to install everything to the Miniconda 3 folder we created, and also remove the original script, and also run conda init to init the conda environment. But conda is not in the binary yet, which is expected, so we don't want conda to be in the environment. We just want to use conda to create the Python 3.11 virtual environment and binaries. So that being said, let's continue. So next, we're going to create a conda virtual environment for Python 3.11. So we just use this bin directly from the Miniconda 3 repo. We don't want to actually create alias or anything like that. We just directly use the conda binary to create this Python 3.11 virtual environment, and also with the Python 3.11 as default Python. So then also we want to create a Python 3.11 virtual environment with PyTorch and PyTorch CUDA installed. So this is optional, but we just install it in case we need it. So then we have to also map the Python 3.11 to the default system Pythons. So because Kaggle doesn't allow you to change of the default settings or the default binaries, so we have to do a soft link to implement this different Python versions management. So then if you look at here, basically first we have to remove the original binary and do a soft link using the virtual environment binaries to the original system environment. So you can follow this script to actually map everything from the virtual environment of Python 3.11 to the default system Pythons. So then when the system is gonna run, everything will actually run using this Python virtual environment binaries. So after that, make sure you also map the 3.11 pip to the system pip, right? So then everything should be all set. Then after that, make sure you also update the environment variables. It's very important to update the path with the virtual environment Python 3.11 bin. Also make sure that you add the Python 3.11 virtual environment set packages to the system path. So, and make sure the result is correct, just running all the script to make sure that the Python is using the virtual environment Python, and also you can see that all the soft links are linking to the virtual environment we created, right? The system binaries are going to link to the virtual environment, so which is good. And we can just run also the versions of Python. You can see everything is set up correctly. So then if you look at this specific cell, we actually did import site and site get packages. So this will actually get the packages that read by the system. So you can see it actually reading from the Python 3.10. This is the reason why we actually create a virtual environment, because the Kaggle kernel will not read from those virtual environment. You have to do a soft link to let the kernel know that you're actually using this new Python version. So, and that if you reducing this Python -c, also run the command, you can see the system is actually reading the latest virtual environment for Python 3.11. But if you run directly in the cell, which is we have to run everything in the cell, so then that's why we have to do the mapping. So this is why we actually create a conda. And also you can also run these different paths to see all the files exist. That being said, all this conda is already set up. If you follow all these steps, then we'll have to install Ollama. So create a function to run bash command within Python, and then also install Ollama using one line command, which is the official way to install Ollama on Kaggle notebooks. And just run the Ollama serve, and also this will run the Ollama in the backend. So, and then we do Ollama pull to pull the Dolphin 3.0, Ollama 3.1, ABGGF directly from Hugging Face with the 4-bit version. And we can run the Ollama list to see that it is installed. So this Dolphin 3.0 GGF is installed. Then we have the install OpenUI. So make sure you clone this OpenUI from the GitHub OpenUI OpenWebUI offshore repo, and then make sure you create a .environment file, then update the environment file with the Ollama base URL, which is local. And then we have to go to this default WebUI folder to actually do a npm install to actually install the front end. But Kaggle has a lower version of npm and also the node, so we have to use higher version of node. To do that, you have to upgrade node using the npm install global node, and also run the go node stable. So install the latest version of the stable node, which is node v2012, which is 22. So this already been updated. So then you go to this OpenWebUI offshore folder, and then basically do npm install a bare bone build. This will build OpenWebUI's front end, and also go to this OpenWebUI backend, do a pip install to install backend dependencies. Then we can install ungrok to actually expose everything from the inside of the notebook to outside. So install ungrok and pyungrok, and also make sure that you paste the ungrok token in the ungrok line here. And after that, just make sure you connect ungrok with your localhost 8080, which is the local OpenWebUI port. So you can see the 92D2 is pointing to the localhost 8080. This is 92D2. This is what we're actually testing right now. So just to refresh the page, you see that it is real. So it's a real testing. So let's go back to Kaggle. And you can see, basically go to this OpenWebUI backend and run bash start sh. You will be able to spin up this OpenWebUI web server. You can see this is spin up. It's on port 8080. So you can see here it's running on 8080. So let's start the testing. And first, basically we're on this Ollama 3.1 ABGGF from Dolphin 3.0, and then basically we just first say hello to test if everything's working. Then we just test a few prompts in here. So first we basically create a Python function that takes a list of integers and returns the sum of all even numbers in the list. Let's quickly test that. Paste. Okay. Okay, seems to be correct. 246 output 12. Okay, this is good. So and then let's say we just mark it as a pass. It's a pass. Let's say solve the following problems. If a train travels at 60 miles for 2.5 hours, then increase the speed to 75 miles per 1.5 hours, then what's the total distance traveled? Let's test that. Okay, so this seems to be correct, in fact. So yeah, the calculation seems to be correct. So let's mark that as a pass, which is really nice. In the third question, we'll try to generate a SVG code for the simple butterfly shape. Let's try that. This doesn't look like a butterfly, so that's not working. So let's mark that I not pass. The fourth question. We have 3 gallons jug and a 5 gallons jug. How can you measure exactly 4 gallons of water? Let's paste the question. So this is correct. Yeah. So okay, let's mark that as a pass. So what's the capital city of the country whose name ends with Laya? I'm referring to the country name here. Okay, let's copy and paste the question. Colombia. No. So basically, I don't think this is correct. So let's mark that as a not pass. And is 3307 prime? Let's paste the question here. All right. So as we can see, it's divisible by 11. So this is not a pass. So not prime, not pass. So it is a prime. So okay, if you have 2 apples and then buy 2 more pie with 2 apples, then after eating half the pie, how many apples do I have left? Let's paste the question. So 2 apples. Good. That's a pass. And then Sally is a girl. She has 3 sisters. Each of her brother has 2 same sister. How many sisters does Sally have? Let's paste the question. Sisters. So that's not a pass. So it's actually 1 sister. So, and the 9th question. Write a Python program that prints the next leap years based on the user's input. Okay, let's run that using the Google edX. Let's copy that. Go to Google edX. Let's create a file. Let's just go to the maybe create another folder. Okay, and in this folder, we just create a file, test1.py. Let's paste the question and run that. 3. How many? 3. Oh, I didn't the starting of the year. So okay. Okay, let's test that starting of the year 2025. Find 3, 28, 20, 32, 36. Oh, that's a pass. Okay, that's good. The last question, we'll create a company's landing page. Let's try that. Okay, very nice. So this is a pass. You can see that's created very nicely. Okay, so let's check how many questions they answered it correctly. So they actually have 60. So 6 out of 10 correct. So okay, I think this is okay. So the model is definitely acceptable. But that's it. So hopefully this is helpful. If you do like this video, please subscribe, like, or comment if you have any questions. Thank you so much for supporting the channel, and see you in the next one.